In this lesson, we're going to look at imaginary numbers. So this is definitely a completely new topic. You haven't done imaginary numbers before, and we're going to start graphically and then work towards the algebra. So on this axis below, we see a sketch of y equals x squared. Now we're going to consider the parabola whose equation is given by the function f of x equals x squared plus 1. So this is a graph of y equals x squared. And you can graph it on your calculator, but you will see that x squared plus 1 is the same exact graph, but it's moved up 1. Okay, so it's shifted 1. I can't draw it perfectly. It doesn't change in terms of width or anything. So I'm sorry that this is off a little bit. Your packet should look right. This function should be right here. This one that's over here. But basically, how is it shifted? It was shifted up 1. What can be said about the x-intercepts of the function f of x? So if I look at this function, right, the new one that I graphed, it doesn't really have any x-intercepts. So there's no x-intercepts. Now we're going to try to solve this to show, set it equal to 0 and solve for x to show that there aren't any intercepts in the real number system. So I'm taking this equation, setting it equal to 0, right? That should find our x-intercepts. And we can quickly see if we solve this, it's an incomplete quadratic, right? So I can isolate my x squared. We get x squared equals -1, and when we try to take the square root of that, we can't take the square roots of negatives in the real number system. So basically, if you think about it, there's a whole lot of different ways that we can draw parabolas or have quadratics that are not going to cross the x-axis, but there are reasons that you would still want to be able to do math with them and talk about their intercepts. So basically, the way we handle this as we create a new number system, which actually ended up this is going to sound kind of weird and like, well, why did they even do that? Not necessary, but it actually has a lot of applications in physics. And it does have a connection with trigonometry, which we'll do later, and you can explore that connection if you take pre-calc. But what they did was they decided that we were going to give this expression a value and use the letter I to represent it. So this I, and I usually write it with a little tail just because then it doesn't look like a 1 even if you can't see the dot up top. I equals the square root of -1. So instead of writing this square root of -1, which we're going to see if we can just get rid of that, we can fix all negative square roots. Now we just say for this problem that x equals square root of -1 is I. Now just like any other time that I'm solving an incomplete quadratic, when I take a square root, I do need to write plus or minus. Now that's not something we can see on this graph. We can't see where I is because that graph is just for real numbers. But there are imaginary answers, and that's plus or minus I. So we're going to see really now any negative square root is taken care of. So even if this was a 9 here, -9, or it was -20 or anything like that, just having the square root of -1 equal I can take care of all those situations. The way it does that is any negative number can be split up into the product of -1 and the positive value of that number. So when I look at this, I know the square root of 9 is 3, and the square root of -1 is I. Now we write the I just like x's go after numbers. We write the I right here. Okay. And so this is 3i. Now I is not a variable. It doesn't change in value. It is always equal to the square root of -1, but it kind of looks like a variable because we use a letter to represent it. So looking at the next one, I can break up square root of -100 into -1 times 100. So square root of 100 is 10. Square root of -1 is I. I'm going to probably I would watch one more because now we're going to have not a perfect square. But basically, you can go and just try this section when you're ready. -32, I could break that up into -16 and 2. So biggest perfect square is 16. We just make that 16 negative. Now, we could break this up more, but based on our last two problems, this is equal to 4, and because it's -I. So you can go right to this and know it's 10i. You can look at this and know that it's 3i. Here, that radical 2 still needs to stay. Looking at the next one, that would break up into negative 9 and 2. So we would write this as 3i for square root of negative 9, radical 2. The next one, people sometimes make a mistake with it because it doesn't simplify at all, but I still have to break it up into that negative and then a positive. So this one is 5i radical 2. We still have a rule that we can't have negatives and radicals, so as you simplify, you have to get that negative out, but the way we get it out is basically by using I. So here, this one is a negative 10 on the outside. We multiply by whatever this is going to be, and square root of negative 25 is 5i. So this is negative 50i. So I, for now, and we'll see what happens with exponents, something a little different when we get to that case. Basically, I works like a variable, even though it has a value, as I said, until we get to exponents. So here, I have negative. I can break this into negative 25 and 2. Now, these two negatives don't cancel because this negative means a negative number and this negative means something entirely different. Basically, it gives us that I, so they don't cancel. So this is negative 5i radical 2. My last one, I have negative 4. 54 has 9 that goes into it, so I'm going to just leave that as 9 and 6. So this is negative 4 times 3 times the square root of 6. So that's negative 12 square roots of 6. So that doesn't have anything with I. So it's not like all of a sudden if that negative sign on the outside does not make a negative sign on the inside. So that's just a normal simplifying square roots.